Hello everyone! In this video we are going to use our Excel sheet in order to help us do an ANOVA hypothesis test. So let's look at our scenario. It says that Blake is working at a convenience store. He's trying to determine if positive or negative magazines at the cash register actually promotes more sales. He decides to test three scenarios, one register with no magazines, one with positive magazines, and one with negative gossip magazines. He randomly selects transactions at each tested register for a day. Blake wants to see which option performs the best for his clientele at the 0.05 significant level. Okay, so let's grab our data. We are going to just go ahead and copy it and paste it into our orange cells. Remember to do paste special and then the text. And here, as we notice, we need to have our groups in column B and the things that we're actually measuring, so the amount spent, in column C, or numerical into C, categorical into column B. Okay, and then we have an alpha level of 0.05, and we can come over here and do 0.05. Let's kind of take a look at what we are dealing with here. So first of all, we have our descriptives, where we have our counts, we have our means, standard deviations, we have a variance check that we're doing, we have our ANOVA analysis, we have a Welch's test, which is just kind of an alternative form of the ANOVA test, and then we have our post hoc comparisons, which is our Tukey HSD, which stands for honestly significant difference, pairwise comparisons that give us our confidence intervals for the differences of each pairwise comparison. Okay, so let's go ahead and start answering our question. So what type of data are we dealing with? So in this scenario, when we're dealing with ANOVA, we're dealing with numerical by categorical data. We have both numerical and categorical, but our categories are just trying to differentiate our groups, and the numerical data is what we are really interested in. The grouping variable of interest here is going to be our magazine status, like were there no magazines, were there positive magazines, or were there negative magazines? The response variable of interest is going to be the amount spent. What we are comparing between these groups is how much money was spent at these registers. Okay, things that are not a population of interest, let's kind of look at these. So we have registers at Blake stores with positive magazines. That's where we're interested in that one. Registers with no magazines, interested in that one. Registers with negative magazines, or registers with all of them. And we did not ever look at a scenario where we had to register with all of them. We could have, and we could have done that in an ANOVA test, but we didn't for this particular one. The parameter of interest is the true mean amount spent at the registers. Okay, and then we have this next question. It's like, can the variances be considered equal? Well, here's the first thing that we need to go and check in our analysis. And we do it the same way that we did our two-sample hypothesis testing, where we looked at the standard deviation ratio. And as long as it's under 2 for our class, we can consider them to be equal standard deviations or equal variances. The more formal way is to do this Levene's test. And because the Levene's test p-value is big, if you want to know, it agrees as well. It says that we have equal standard deviations. And so here we can say that yes, the variances can be considered equal. For our class, we're looking at the standard deviation ratio being less than or equal to 2. And remember, the standard deviation ratio, what it does is it takes the biggest standard deviation, which is 5.96, and divided by the smallest one, 5.08, and we get a ratio that's really close to 1. So the method that we should be using to attain our statistic here is going to be the ANOVA method. Because we're comparing means between more than 2 groups, we need to use ANOVA. Because of this, the distribution and like the test statistic that we're going to be interested in is our F statistic. And then the next thing is that we need to kind of address to see if we have normality. And the way that we do this is we start looking at our QQ plot, which is provided to you over here. So we have this QQ plot, and I could dive into what the QQ plot actually is, and we're mostly just going to talk about how to use it. And essentially what we're looking for is for this QQ plot, we want our data points to be landing on this straight line. Now, when we're dealing with data, we almost always have deviations, little deviations. This looks really good. If we had some major deviations, like it looked like some big cubic or a sinusoid, or we had, I don't know, where we had some weird pattern going on, then we would say that it doesn't look like a straight line. But here, we're going to say that yes, it does look like a straight line. And if it lands on a straight line, then we have our conditions of normality. It means that our data is essentially normal. Now, unlike doing one sample or two sample hypothesis testing, there we had the central limit theorem to bail us out. Here we don't. Here we actually need to have basically, we need to have some requirements of normality met, and we use the QQ plot to check it out. Okay, so we are able to meet those, and now we can kind of go down and establish our hypotheses. Now our hypotheses are a little bit different this time. The null hypothesis is that all of these registers, regardless of the magazines, have the same amount spent. So you can say that the true mean amount spent at each register for each group is the same. So that's the null, is that they're all equal. Now the alternative hypothesis is not that they are all not equal, but it's that at least one group's true mean amount spent at the register is different from the other. We don't have to have all of them be different. We just need to have one be different in order for us to make the claim. Okay, so we need to identify our alpha. And if we go back up to our problem, it said that we're at the 5% significance level. So that is our alpha level. And then we need to collect our tests, like test statistics and sample statistics. So our X bar 1 of no magazines is 47.8471. And if we click on this, 47.8471. Positive magazines, we get 4696, which matches up over here. And the last one should be 4841. And we look pretty good. Great, so we have these. And then we need to also come down here and talk about, okay, which of these, we have kind of this F statistic and a p-value, and we have an F statistic and a p-value. One is from like the ANOVA, and one is like using a Welch's test ANOVA. Okay, so just like how we had differences between one sample, or between when we did equal variances or unequal variances, we have the same thing here. If we have equal variances, we just use ANOVA. If we have unequal variances, we use Welch. Because we have equal variances, we're going to use the ANOVA stuff. So we see that our F statistic is 0.616, and that is what we got here, 0.6161, rounded to 4 decimal places, and a p-value of 0.517. Okay, so if we compare our p-value to alpha, we see that the p-value is greater, and that means then that we are going to fail to reject the null hypothesis. Okay. So now let's look at our conclusions, and we can see here that it says that Blake collected insufficient evidence. Now we report our statistics. Okay, here's how you do it. When we do our F stuff, we do F, degree of freedom 1, degree of freedom 2. So F is here, degree of freedom 1 is the 2, degree of freedom 2 is this 128. So you kind of go like this. Then you report your F value, you report your P value, and your alpha. So we collected insufficient evidence to reject the claim that the true mean amount spent for each of these scenarios, no magazines, positive magazines, and negative magazines, are equivalent. We didn't get enough. And because of that, we have insignificant results, and our confidence interval is not required. Now, there's a warning here that due to programming limitations, the reported confidence interval will be slightly different than what you see in, it says R Commander. That was another program that we used, but they're going to be slightly different than what you see in Excel. They're going to be close, but again, because of some programming limitations in my Open Math, they will be slightly different. They'll be close, but they'll be different. Okay, so before we go on, like even though that we don't need a confidence interval, let's see where we would get them if we did have them. So if we did have significant results, we would then want to know, okay, which groups are different and by how much? And that's where this 2-key pairwise comparison comes in handy, where they compare group 1 to group 2, no magazines to positive magazines, no magazines to negative magazines, and positive magazines to negative magazines. Now, if we had another group in there, we'd have a couple more comparisons. This table here in ANOVA, I do believe I have it set up to handle up to 5 groups. If you're doing more than 5 groups, and in our class we keep it 5 or less, but if you needed to do more, you'd need to use a better program than what we're using for this class. Okay, but if you need those confidence intervals, we can see this lower and upper here, lower and upper here, and lower and upper here. And what we notice is that each of these span from negative to positive, negative to positive, negative to positive. So that means that 0 lands in here. And if 0 lands inside our confidence interval, it means that it's likely, or there's a good chance, that these two groups could be the same, right? No magazines minus positive magazines. If it equals 0, it means that, I guess it really doesn't matter what we put at our registers magazine-wise to improve sales. Now, if we go over here, there's this really great graphic here. And this is a graphical representation of our Tukey pairwise comparison. So this is the confidence interval for the first two of no magazines minus positive magazines. This is no magazines minus negative magazines, and positive magazines minus negative magazines. And how we read this is that these are kind of the lower and upper bounds on each of these intervals. And then we have this red line going across. And the red line is representing kind of our null hypothesis. And we notice that each of these pairwise comparisons capture our null hypothesis. And so overall, we had insignificant evidence, or that our evidence didn't suggest that any of these pairwise comparisons were different from one another. Okay, so that's how you do a ANOVA hypothesis testing. If you do find significant differences, you will need to look at which of these intervals are different. So let me just look at another version of this really quick. So let me just grab a new version. And give me a second. Okay, and then I'm going to scroll down. I'm going to kind of cheat real quick and see if I have, yep, okay, I have significant results in this one. Let me clear the data real quick. Okay, cleared out my data. I'm going to grab my new data, copy it, paste it in here. Text, okay. Paste it in, 0.05, hit enter. Okay, let's take a look at this one. So this one, I'm not going to go through all the steps again, but I just want to go and look at the very end of kind of like our conclusions. So our confidence interval plot decision, what we can do is we can say reject the null. So we can, if we want to look at our confidence interval plot decision, check this out. We can go over here and notice we have two of them that don't include the hypothesis of 0. So that's kind of like our decision. Are we going to reject the null or fail to reject the null? We can also do that by looking at our p-value, and look at how small our p-value is. It's much, much less than this alpha of 0.05. Okay, so our conclusion here is going to be Blake collected sufficient evidence. We put all of our evidence in here to reject the claim that the true mean amount spent for registers with no magazines, positive magazines, and negative magazines are equivalent, and instead to conclude that at least one pairwise comparison of the true mean amount spent was found to be different. Okay, that's our conclusion. Now we look at our confidence interval. While conducting the Tukey post hoc analysis at the 95% confidence level, Blake found significant differences. Okay, now here we have to talk about all of the significant differences. We got to talk about them all. So let's go ahead and take a look at them. So notice here how we looked at, said no magazines and positive magazines. Those ones were different. Look at our p-value. Our confidence interval does not contain 0. So we can say that here, no magazines had a more spent than the positive. And we say here that no magazines and, let's see. Let's read this real quick. Blake found significant difference where positive magazines had significantly smaller mean amount than no magazines. And that's what we see here. Now notice the numbers are slightly different. They are close, but they're slightly different. That's what I mean by the programming limitations. And negative magazines. So if we look at negative magazines had a more than our positive, and so that's why we see that it's negative here, and we have significant results. We can also look at this over here. No magazines minus positive is up high, so positive is smaller. Positive magazines minus negative magazines, if negative is bigger, that means that the positive magazines are smaller. That's another way that we can kind of see that. And then also you can kind of see, like if we find these two significant results, we can just go back and look at the means and notice that positive magazines is smaller than both of those comparisons of the means. So that's how you do it if you have significant results. Sometimes with significant results, you only have one group that's different. Sometimes you have where two, and sometimes you have where all of the groups are different. Whatever the case, when you are writing that confidence interval statement at the end, you must talk about all of the ones that were significantly different. Provide the confidence interval and their respective p-values. And for this one, I just did p-values of less than 0.05. If you're writing them yourself, you can include these exact p-values here. Okay, That's all that I've got. Good luck on doing your ANOVA testing using our Excel tools.